So we've talked about instance methods, and in this video I want to talk about something that is called method overloading. So let's say we want to define a method that computes the distance from this point to the origin. Okay? So we could do that very easily. We could say double distance to origin, and then of course this would not receive any parameters because we already know what the next point is going to be. So we could just say return. So let's just copy this code actually. So let's say that we know that this is going to be 0 minus this squared, 0 minus this squared. So yeah, so it's just the distance between, it's really just the Pythagorean theorem at this point. It doesn't matter. And yeah, so let's just simplify the code. So the distance between this point and the origin is just the Pythagorean theorem. So we're done, right? Very simple. So we could test this. You know, if you were writing this, you would of course do the comments first, then the test cases, and then the implementation. But there's something I want to say about this method that is very sort of particular. So we wrote a specific method to compute the distance from this point to the origin. But we could just do that directly, right? We could just do something like p dot dist. So we could say like let's create a point 3, 4, and we'll say that this is 5 because the distance from p to the origin would be p3. So this would be 25. Square root of 25 is 5. Okay. So, but the issue is that we wrote an entirely separate method to do something that we could just do this with. Right? We could just do new point 0, 0. And we get the same effect. Right? Yeah. So, this is not very good practice. So what we could do is, let's say that we want to define a version of distance that if we give it no parameters, that we will assume that that returns the distance from this point to the origin. So in fact, we'll make this a comment. So returns the Euclidean distance from this point to the origin, which is 0, 0. Like that. Now, so this is now better. So what we can do is just copy this test case and then get rid of the parameter, and we'll see that it still works the same. But there's still some duplicate code here, right? We still had to copy this whole thing and put it here, and just change this right here. But why not leverage this method? And indeed, we can do that. We want to call this method with a point of 0, 0. So all we have to do is say return distance and pass it a point 0, 0. Okay? And one thing I like to do is you can also prefix it with this to say that we are calling this distance. Remember, this is an implicit parameter. So we're saying that we're calling distance on this point and computing the distance from this to the origin. Okay? So, when we call p3.distance, p3 will become this when we call this version of distance, and then it will be translated into this when we call this version of distance. Okay? So, all we're doing is we're just calling this version of the method with a different parameter. Okay? And like I said, this is called method overloading. And all that means, so overloading a method just means that we are changing the parameters of the method, but keeping the method name the same. Okay? So we call distance with a different number or different types of parameters. In this case, it's the number of parameters. And if we call distance with no parameters, then we assume that they want to compute, they being the programmer, they want to compute the distance from this point to the origin. So to avoid duplicating code, we just call that version of distance with the origin point. Okay? So that's overloading an instance method. There's another thing we could do as well, and that's called overloading the constructor. So let's say that we want to overload the constructor to say that, well, let's back up. So when we first started off objects, we said that by doing this, by saying new point without any arguments, that was called the default constructor. Okay? And what that would do is assign the instance variables x and y to be default values of 0 and 0, because that's what the default value is for integers. Okay? But the problem now is that the default constructor goes away, so to speak, when we create our own constructor. Okay? So what we now need to, or let's say that what we want to do is we want to get that behavior back. We want to say that if we say new point with no parameters to the constructor, that creates a point at the origin. Okay? So effectively we could just remove this and make it this, and then that would create a point at the origin, 0, 0. Okay? So how do we do that? Well, we can overload the constructor by doing the same thing. By just saying point and then doing nothing. Or passing nothing, sorry, not doing nothing. Then we could say this dot x equals 0 and this dot y equals 0. Okay? And then everything should still pass and we're good. But there's still one little bit of redundancy here. Let's say that this method had a bunch of other parameters. Like let's say this was a 6-dimensional point. I don't know. Has 6 values, 6 integers. Okay? And we want all of them to be set to 0 when we create a constructor of no argument, or when we call the constructor of no arguments. That means we'd have to copy all of these and do this dot x equals 0, this dot y equals 0, this dot z equals 0, this dot w equals 0, so on and so forth. And that's very redundant. What we can do, very similarly to distance, is we can call this version of the constructor. We can do that by saying this without a name. Okay? And what values do we want to call that constructor with? We want to call it with the values 0, 0. Okay? So doing this will call this version of the constructor, because it has 2 arguments, and assign the instance variables appropriately. Okay? This is what's called constructor chaining. And all that means is that we call one version of a constructor from another constructor in the same class. Okay? And this is really, really nice for reducing duplicate code. Okay?